Came a little prepared. So, review of the steps we use. So first thing that Juliana did in our warm-up was we got the trig function by itself on the left. Yeah? And remember, those trig functions need to be sine, cos, or tan, because those are the trig functions on the unit circle. If I want to use the unit circle to find my answer, those are the ones I'm wanting to write it as. If it's cosecant, secant, or cotangent, I should rewrite it. And then we use either the unit circle, if the answer is on the unit circle, or our calculator. Come on, pen, calculator. There we go. And we use our inverse trig functions on the calculator to find the angle. So if our answer's on the unit circle, that's the route we take. If it's not, we're going to use our calculator. And I'm going to get mine out. You should get yours out, because we're going to encounter one or two of these today. We're going to do some calculator math. Yeah. Okay. So all we're doing today are some examples. Yeah? Practice with this technique. So I'm going to scoochie this up a little bit. We'll do our first example. It says solve on the interval 0 to 2 pi. And the equation we're solving is tan theta minus pi over 2 equals 1. That looks different than the ones we saw on Friday. The messy algebra isn't outside of the tangent, it's inside of the tangent. The tangent's all by itself, but the argument inside the tangent's gross. When I see things like this, I'm going to use a trick that we're going to use a couple times today, which is a variable replacement. I'm going, maybe if I can get my pen to work, I'm going to let that ugly mess, theta minus pi over 2, that I don't want inside the tangent, equal a new variable. I'm going to give it a new name. Suggestions on what I could call it? X. X is a good suggestion. It's our default unknown. Yeah, let's call it X. So instead of writing tan theta minus pi over 2, I'm going to write tan x equals 1. That's something I know how to solve. If I go to my trig function, or my unit circle rather, tangent equals 1 means sine over cosine is 1, right? Which means y over x is 1. That only happens when y or x are the same number, right? 5 over 5 is 1. X over x is 1. So I'm looking for points on the unit circle where the x and y coordinates match. Where does that happen? Two angles. Where does that happen? Pi over 4. Perfect. Root 2 over 2, root 2 over 2. So that's one of my answers. And 5 pi divided by 4. Very good. The other guy is right here, right? Negative, negative makes positive. Positive, positive makes positive. It has to be those two because it was a positive 1. The other guys would give me a negative 1. And normally we'd be done. But we're not done because the variable we were asked to find wasn't x. What were we actually solving for? That theta minus pi over 2. So I'm going to go back to what x is equal to and resubstitute in theta minus pi over 2 for x. If x is equal to pi over 4, theta minus pi over 2 equals pi over 4. Theta minus pi over 2 equals 5 pi over 4. I get two new equations. And I want to solve those new equations for theta. So I know theta minus pi over 2 is pi over 4. How do I undo that minus pi over 2? Add it with confidence. Yeah. Plus pi over 2 plus pi over 2. Got to do it to both sides of the equation. Yeah. I know when I add or subtract fractions, they have to have common denominators. What can I multiply 2 by to turn it into 4? 2. So top and bottom by 2. Top and bottom by 2. So this first guy, 5 pi over 4 plus 2 pi over 4 is 7 pi over 4. My first answer. Over here, I get theta equals, and then pi over 4 plus 2 pi over 4 is 3 pi over 4. So my answers are not here, my answers are here. They've been shifted forward by pi over 2. Because that's what sticking minus pi over 2 inside the trig function does. It's a horizontal shift forward. Those of you who needed to leave it 2, it's 2. Yeah. So we've learned something new. If the algebra is outside the trig function, 2 times tangent plus 5, and it's all outside the tangent. We do the algebra first, and then we go to the unit circle. If the algebra is inside the trig function, it's the argument inside the trig, we go to the unit circle first, and then we do the algebra. So it matters whether the algebra is outside or inside the trig function. If it's outside the trig function, do the algebra first. If it's inside the trig function, do the unit circle first, algebra last. Yeah. Okay. Let's try a couple more. We started to like devolve into each other. I have to write smaller. Next one says solve on the interval 0 to 2 pi. 2 times tan theta plus 3 equals 5 plus tan. Why do I have tan x and tan theta? Mr. J. Let's make those both tan x. I don't know what I was thinking when I wrote that. And we're going to ask Alfredo. Alfredo, I want to solve this trig function. What's the first thing I should do? Ooh, good suggestion. So we need to rewrite it. Let's distribute that 2. Get rid of the parentheses. That's an excellent suggestion. 2 times tan x is 2 tan x. Plus 2 times 3 is 6. we didn't touch the right side. That's nice. Hello, Desi. What comes next? What's my goal? What's my goal, Nick? What's the point of all this rewriting? You should have written it down as the review today. Top of the review, the very first step we do. Did we write it down? Isolate the trig function. Very good. I need to get the trig function by itself on the left. I have trig functions on both sides of that equation. That makes me unhappy. I have a 2 tan, I have a tan. How do I move this guy to the left? What was that, Alexis? Subtract. Yeah, he's being added. Let's subtract him. Minus tan x minus tan x. Yeah. On the left, I have 2 tan x minus 1 tan x, which leaves me with 1 tan x. So tan x plus 6 equals, on the other side, I had 5, and then plus tan minus tan is just 5. So far, so good. Last step. Omar, what do I do last? Get the tan by itself. What am I subtracting? Yeah. Focus on the side with a tangent. Perfect. Get those 6's to cancel. Tan x equals -1. We go to the unit circle. If it's -1, y and x should have the same value, but opposite signs. One is negative, one is positive. Where do we see that happen on the unit circle? 3 pi over 4. Right here, there's a minus and a plus. And 7 pi over 4. Yeah, here. Plus and then a minus. So x must be 3 pi over 4 or 7 pi over 4. Happy face. Yeah. Get the trig function by itself on the left, numbers on the right, go to the unit circle, yay. We can do this, yeah? Don't judge me. Yes? Here? So remember that when we have a trig function by itself, just like a variable by itself, the coefficient is 1. This is 1 tan x. 2 tangents minus 1 tangent leaves me with 1 tangent. Yeah. Yep. We count tangents just like we count apples and oranges. I have 2, take away 1, I'm left with 1. Yeah. No, that was a good question. Other questions? Are we still conscious today? Let's try another one. Scooch you up here. Next one says solve. State your answer in radians. And it just says sine theta equals 0.8. So first step, get the trig function on the left by itself, numbers on the right. To me, it looks like that's already done. Sine theta is on the left, numbers on the right. The next thing I do is check the unit circle. Is 0.8 anywhere in those ordered pairs for the unit circle? No. I cannot solve this with a unit circle. This is a calculator question. Anytime something over here on the right does not fit on the unit circle, it's calculator time. And the question is, how do I undo sine on a calculator? Sine inverse, yeah. Sine inverse of sine of theta is just going to be theta, and I'm going to have sine inverse of 0.8. So these guys cancel. Theta is whatever my calculator spits out for sine inverse of 0.8. There is a catch. What unit do we want our answers in? Radians, which means your calculator has to be in radians setting when you evaluate an inverse trig function. For inverse trig functions, the unit on the calculator is the units it's going to spit out as your answer. So on my calculator, I check on the upper right corner that it says radians. If it's not, I press mode and I fix it. And then second sine 0.8. Yeah. And I, when I do it, get 0.927. And I get agreement. And that's it. That's it. That's it. That's it. Yeah. We can manage that. That's doable. Yeah. So far, so good. Yeah. Sometimes these equations are going to show up where there's some algebra first, and after you do the algebra, the number that's left over here won't be on your unit circle, and that's when you grab the calculator. This one was just straight to calculator, which was nice. Okay, based on what I've seen, you guys are doing pretty well with this. Let's move on to something slightly trickier. Wait, why are those so on top of each other? I don't know. I lost my mind. That's what happened there. That shouldn't be there. Let's move that this way. We'll do that next. All right, so number 4 says solve on the interval 0 to 2 pi, and the equation is cos squared plus 3 cos minus 1 equals 0. And Melissa's shaking her head no, like that's the worst thing she's seen today. So that looks a little scary because now there are exponents in there. But as experienced mathematicians, if I ignore the fact that it's a trig function, that format, something squared plus something plus a number equals 0, looks familiar. You saw it for an entire semester in Math 2. What type of equation is that? Starts with a Q. Your Math 2 teachers are like so proud right now. When you plot it, it makes a U shape. Quadratic. Yeah, this is a quadratic. Yeah, and it's difficult to see with the cosines in it, so I'm going to do a variable replacement. I'm going to say let cosine of theta equal x. Let's remove the trig functions from the issue and just solve the equation looking at its basic structure, and then deal with the trig function at the end. So I'm going to rewrite that, and everywhere I see a cos, I replace it with an x. So cos squared is just x squared. And then I have 3 times a cos, so 3 times x, minus 1 equals 0. And to me, that looks way less scary. That's something our sophomore selves knew how to solve. Yeah? 2 obvious choices, factoring or quadratic formula when we're solving a quadratic equation like that. First is we try to factor, because a is 1. Yeah? No coefficient front. So we look. What numbers multiply to -1 and add to 3? Two times 1 is 2. What two numbers multiply to 1? 1 and 1. 1 plus 1 is 2, not 3. I cannot factor this. It's not factorable. Brownie face. So the only other option, quadratic formula. Yeah. So A is 1, B is 3, C is -1. We have to sing the little song in our head. Minus B plus or minus square root of B squared minus 4AC all over 2A. If they only remember one thing from sophomore year, that should be it. So X equals big fraction. Negative B, so -3 plus or minus square root. B squared, 3 squared is 9, minus 4 times A times C, all over 2 times A. That's not even trig, that's just algebra, yeah? That's old school math. We want to make it pretty, because we might end up with something on the unit circle, and we'll know how to deal with that. So let's simplify, starting with the inside of that radical. -1 times -1 is +1, so this is a +4. What is 9 plus 4? 13. So this is X equals -3 plus or minus root 13 all over 2 times 1 is 2. And that is not one answer, but 2 answers, because I have a plus and a minus. Yes? So I'm going to do 2 things here. I'm going to replace the x with cosine, so cos theta, and then I'm going to separate it into 2 separate equations. The plus first, -3 plus root 13 over 2. Or I could have cos theta equals -3 minus root 13 over 2. And I know, because I know the unit circle pretty well at this point in the semester, that -3 plus or minus root 13 is nowhere on that unit circle. This is a calculator question. We need to do cos inverse of this thing to get a value. We need to do cos inverse of this thing to get a value. That's how we undo cos. We're going to do cos inverse. So this guy up here, we do cos inverse. He's going to give us an answer. I will do it with you. So second cos. Remember to put parentheses around your numerator. I get 1.263. I don't hear any arguments. I'm going to do the same thing with the second guy. Another cos inverse. Second entry, go change that plus to a minus. And what does your calculator tell you? Error. Yeah, gives you an error. The reason it's doing that is, remember when we looked at inverse trig functions, they only exist for a specific part of the unit circle. Cosine only existed from 0 to pi. -3 minus root 13 is less than 0. That's not in cosine inverse's defined range. That is not acceptable for cosine inverse. Yeah? So this answer here isn't going to give us a valid answer. This is the only answer that works for the function we have. Yeah? Which is nice. Calculators are going to tell you when you're out of bounds, right? If you get an error, that's not a possible solution. Whereas with the unit circle, we have to visually check, did our answers end up in the range we want them to be in? So calculators are nice that way. Yeah. Deep breath. We're going to try another one. Yeah? I'm going to have you help me with this one. Yeah? Let's scooch you over. Next one says, solve on the interval 0 to 2 pi, 2 sine squared theta minus 5 sine theta plus 3 equals 0. So I'm going to give you about 30 seconds in your small groups. Chat, how would you start this program, or problem? How would you tackle this? This looks similar to the last one. What's your first suggestion? 30 seconds. If you're facing the TV, you should be the discussion leader. Talk to your neighbors. Figure out where my little... I'll pull that up in a minute. All right, volunteers, before I use my random name selector, what should I do first? Paul. Variable substitution, sine theta equals x. So 2x squared minus 5x plus 3 equals 0. Did anybody have a different suggestion? I see some shaking heads no, some people decidedly not looking at me in hopes I won't call on them. Very good. 2 ways to solve quadratics. Factoring and then quadratic method. Check in that order. We should check if we can factor this first. So I'm going to look at, because this is not 1, I need to do first times last. So 2 times 3 is 6. Yes? I'm looking for all factors of 6 that add to minus 5. And there's only a couple of pairs. We could have 5 and 1, so we could have 1 and 5, which are going to add to 6. We could have minus 1 and minus 5, which give you minus 6. We could have 2 and 3, which add to positive 5. I think negative 2 and negative 3, which will add to negative 5, are what we want to use. They multiply to positive 6 because negative is positive. They add to negative 5, which is my middle term. Most people do okay with this step when they factor by grouping, but then they forget what to do with those 2 factors. With factoring by grouping, we take that middle term and we split it up into negative 2 and negative 3. And you always put the bigger absolute value first. So when I rewrite this, I'm going to have 2x squared minus 3x minus 2x plus 3 equals 0. Right? If I group those back together, they'll give me back the minus 5 I started with. But if I do this correctly, I should be able to factor the first pair of terms, something they have in common. I should be able to factor the second pair of terms, and they should leave me with a binomial that matches. And that's why it's called factoring by grouping. We split that middle term, and then we group the terms together to factor. We're going to start with the first pair, 2x squared minus 3x. What do they have in common that I can factor out? An x, yeah, let's pull an x out. I'm going to divide an x out. 2x squared divided by x. What am I left with? 2x, yeah. Minus, and then 3x divided by x is 3. Yeah, I agree. So 2x squared minus 3x is equal to x times 2x minus 3. And that first factoring gives me a clue of what I'm looking for in the second, because I want the binomial that's sitting here for that second factoring to be the same as the first binomial. I want it to be positive 2x minus 3. And if I look at what I want versus what I have, what's the difference? Negative sign. Let's factor out a minus 1. Yeah. If I divide negative 2x by negative 1, I get positive 2x. If I divide positive 3 by negative 1, I get negative 3. And if we did this correctly, and we did, those binomials should be the same binomial, 2x minus 3, 2x minus 3. We're going to factor that binomial out in front. 2x minus 3 plus something gives me 0. Yeah. When I divide out that binomial in the first term, I'm left with an x. I divide out the binomial in the second term, I'm left with a minus 1. So 2x minus 3 times x minus 1 equals 0. If you are not good with this yet, because this is a higher order factoring method, right? This is complicated. Foil that out, make sure you get back to where you started. Yeah, because if you factored correctly, it should land you back where you started. I'm going to use the zero product property. If I multiply two numbers together and my answer is 0, one of those two numbers was 0. Only way to get 0 is an answer. So I know either 2x minus 3 is 0 or x minus 1 is 0. And that's going to tell us what our x values are. Yay! 2x minus 3 equals 0. I'm going to add 3 to both sides. I'm going to divide by 2. And I'm pretty sure that gives me x is 3 halves. I don't hear any argument. That's happy face. The other equation, I'm going to add 1 to both sides. I get x equals 1. Am I done? Was I asked to solve for x? No, no, I was not. We made a variable replacement way back at the beginning. We said x is equal to sine theta. So what that actually tells me is that sine theta equals 3 over 2, and sine theta equals 1. Now that I've got statements with a trig function on the left and a number on the right, I check my unit circle. Is 3/2 anywhere in those ordered pairs? Three halves on there anywhere? Not talking to myself up here. There's a root 3, but is there just a whole 3/2? No. This is a calculator problem. Is there a 1 anywhere in the y coordinate? Yeah, at pi/2 at the top of the circle. This one is a unit circle question, right? I know that theta is pi/2. This one is a calculator question. So I have to do sine inverse of 3/2. That one's not on the unit circle. So this is a mix of both. One solution is unit circle, one is calculator. So we grab our calculator. We exit the error from the last problem. Second sine 3 divided by 2. You run that on your calculator. What do you get? You get an error. Yeah. Sine inverse only accepts input from negative pi/2 to pi/2. 3/2 is outside of that. And so it will spit out an error. This is not a solution. This guy is. Happy face. There are some patterns here. Like all quadratics that we saw in pre-calculus and that you saw in Math 2, because you have an x squared, you usually get two solutions, right? There's two intercepts when that parabola crosses the x-axis. When we bring trig into the picture, trig is going to limit those. So yes, in theory, the quadratic gives rise to two solutions, but one of them might not agree with the unit circle we're dealing with, yeah? Or the trig function we're dealing with. So the quadratic limits it down to two solutions. The trig function is going to narrow it down further. Yes, you may. Take a pass. Yeah. Thank you. Okay, I'm going to pop another one up there. I want you to try it in your small groups because it's good for you. Wait, where is it? Here we go. Okay. So try that first one, ignore the second one. It says solve on the interval 0 to 2 pi, not negative, sorry. Where did that negative come from? 2 sine squared theta minus 3 sine theta plus 1 equals 0. Which is not the one we just did. Yes.
I don't really understand what he did with this whole factoring. If I don't want to go through this process, can I just do the
Quadratic formula?
Yeah.
You can always do the quadratic formula, yeah. Let's go ahead and go through this. Who can tell me where to start? Somebody who hasn't talked yet, preferably. Where do I start? Omar, first suggestion, what should I do? Good? And then how did you tackle that? That's where you got stuck. Okay, so two choices, factoring or quadratic formula. Somebody give me a preference. Quadratic. Okay, so A is 2, B is -3, C is 1. I'm going to get x equals minus a minus 3 plus square root of 9 minus 4 times 2 times 1 all over 2. Simplifying inside the radical, 4 times 2 is 8, 8 times 2 is 8. It's negative, so 9 minus 8 is 1, and the square root of 1 is 1. So this is 3 plus 1 over 2, and 3 minus 1 over 2. Not over 2. 4, thank you. I forgot my A in the bottom. Shame on me. So that's going to give me x equals 4 over 4 is 1, and 2 over 4 is 1/2. I see nodding. Good. And x equaled what? What did we let x stand for? Sine. So sine theta equals 1, or sine theta equals 1/2. So we check the y coordinates, sine is y. Where is sine equal to 1? Pi over 2. That gives us one solution. Where is the y coordinate equal to positive 1/2? Pi over 6, 5 pi over 6. Yeah. Perfect. Perfect. Yeah. Would you do me a favor? Grab a wet wipe and wipe it down. I trust you, I just don't trust the other surfaces in the bathroom. And I have to hang on to them all week, so I'd like to keep them clean. Okay, hopefully that's feeling a little bit more comfortable. I'm gonna have you try one more in your small group. Yeah, as practice. So I'm gonna scoot you up to this last example. Similar, it says solve on the interval 0 to 2 pi, 2 sine squared theta plus sine theta equals 0. I'll give you 5 minutes. That one's a little trickier. We have to think more carefully about how we factor. Oh, Naughty has it. I think Naughty has it. All right, let's go ahead and go through this. So it's 2 sine squared theta plus sine theta equals 0. How do I start? Giggly back table, would we like to contribute?
I put let
Sine theta equal x. So you did a variable replacement? X squared plus x equals 0. Okay. Very good. Somebody else, suggestion on where to go next? 2 ways to solve this. We could factor, we could use quadratic. Who's got a method they prefer? Quadratic? Jen says quadratic. Okay, so A is 2, B is 1. What is my C? 0. Yeah, there is no constant term there. There is no third term. It's just the x squared and the x. So x equals minus b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Inside, 4 times 2 times 0 is 0. So that becomes square root of 1, which is 1. So I have minus 1 plus 1 over 4, and I have minus 1 over 4, which gives me x equals minus 1 plus 1 is 0. And minus 2 over 4 is minus 1/2. I don't hear any protesting. I see nodding. And then we come back up here to that variable replacement. So that means sine of theta equals 0, or sine of theta equals negative 1/2. And those are numbers on the unit circle. Where does the y-coordinate equal 0? 2 pi also, we'll start with 0. Smallest value first. Where else? Pi. Yeah. And then 2 pi, and then 3 pi, and then 4 pi, because it keeps going around in a circle. Good. Where does the y-coordinate equal negative 1/2? Those are the 6's. Yeah, this one is 7 pi over 6 and 11 pi over 6. Right, negative is in the bottom half of the graph. Yeah, yeah. Very good. Very good. All right, questions on what we just did or on the process that we're using to solve these? Thank you. I'll take the deafening silence as a no.